done is I put together a little Google form for you to follow along with. It's called number 157, Metals, Trends, Fire. Okay. If you're on the Zoom, I just put it in the chat. Number 157, Metals, Trends, Fire is the name of the, how did somebody, you can't, somebody, I haven't done it yet. Somebody turned it in. I don't know how you did that. I haven't done it yet. Okay. Don't get your last name incorrect. Okay. Don't get your last name wrong. That's weird. What makes an atom more reactive? Okay. Okay. Cool. So here's what's going to happen. I'm going to go through the questions. Then I'm going to move the picture up onto the screen. So I got to do some, yell at me if it feels like I'm not showing the right thing on the screen. Okay, what makes an atom more reactive? So reactivity in atoms is all about moving around electrons. So not necessarily bigger or smaller, but just if something very easily gives away its electrons, then when it comes near something that might want electrons, it'll give them away and you'll have a chemical reaction. If you have something that is grabbing electrons, when it gets near some things that have electrons, it's going to pull electrons away and you will get chemical reactions. So if you're not sure what that means, I'm going to try and show you that when I put some lithium into water. So lithium has, I'm going to make, oh, you know what? I'm going to take a screenshot of this just because I can. I think I can. No, I can't. I got to do this. I don't have that software anymore. Oh, yeah, I don't, okay. It's going to tell me I can't do that. Garfunkel. All right, lithium. So we're going to look at lithium first. Actually, we're going to do lithium, and then we're going to do sodium. So we're going to look at lithium. So lithium is right here. It's got one valence electron. And ionization energy, if you didn't see ionization energy, it's pretty low. It pretty easily removes or lets go of an electron. So let's see. Pin video. All right, so now folks in the room, you're looking at this thing right here. I'm going to put some goggles on because we're about to do some chemistry. If you can't see the board, wiggle yourself where you can see the board. I'm going to put some lithium into water. Oh, lithium, metal or non-metal? It's a metal. It's on the far left-hand side of the periodic table. So if it's a metal, what should it look like? Like a metal. Yeah, like you're like, that's a dumb question because we all know what metals look like. They look like metals. Sorry, I didn't think it was a dumb question. But what should it look like? Tell me, what are some words? Solid. What else? Metals. Grayish. What else? Gray or shiny or both? Ooh, it should conduct electricity. So I'm not going to put my conductor on there, but does that look gray and shiny? Yeah. It looks gray and shiny. Let's see. Can you see here? You can't see there, but it's gray and shiny. And now you're gonna describe what happens, which means you just write down what happens when I put it in the water. You hear that? Do we have a chemical reaction happening? How do you know? We got bubble. We're making a gas. Do you guys see? If you see bubbles, we're making a gas. What is that thing in the bottom there? It's throwing me off. It's a It's making a gas over there. It's not a good gas. Okay, so you should have just described what happened, and then I'm going to try and explain what happened. So let's go. Where did I go? This goes away. And I go back to this. And I go back here. All right, describe what happens when the lithium goes into water. For someone who didn't see it, Abby, what happened? It dissolved. It went away. We no longer see it. What else? It made what? Sizzling. Was it? It was like you could hear it reacting. Sizzling. Did it make bubbles? You should have seen some bubbles. So why does this happen? Mr. Mello is going to try and explain it. Hi, I'm Mr. Mello. I'm going to try and explain this. We have lithium atoms. What other atoms are there? H2O. So we have H2O. Those are the only atoms that were reacting. Okay. Ooh. So what we saw a gas. What is our possible gas? We could have made oxygen. What else can we make?
Carbon dioxide.
Can we make carbon dioxide? We can't make carbon dioxide. There's no carbons. We can make hydrogen gas. So yeah, we can make hydrogen gas. And later on, yes, sir? What hydrogen? I don't know if it is either. So here's what actually happened is lithium has one valence electron, right? The reason hydrogen is bonded to oxygen is because it has one valence electron and it shares a valence electron with oxygen. But lithium just gives this to hydrogen. And then what happens is you end up having hydrogens stick together and you get this weird compound called lithium hydroxide. So this is our gas. And this is a base, which is the opposite of an acid, which we'll get to yet. That's weird. But it also makes that water right now not good water. My wife's calling me. I can't. I'm not. Maybe she'll call back. Okay. So did I explain what happened? So we're making a gas and a base. We're rearranging the atoms, the water molecules to hydrogen gas and lithium hydroxide. So here's my question for you from the simulation. Do you expect sodium to react like easier or is it going to be easier for sodium to react or harder for sodium to react? I'm going to get some sodium ready while you try and answer that question with your buddy. How is sodium going to react different than lithium? Looking at the board up there, talking about things we talked about. Is that my lithium? That's my lithium. That's a poor people's door. Oh. All right. Sodium, more reactive or less reactive? What do you think? Yell it out. What do we got? More reactive. How come? They both have one valence electron. Which one's valence electron is going to be easier to give away? Which one's bigger? Sodium's bigger. So which one's valence electrons are going to be easier to remove? Sodium. Okay, so sodium is bigger. It's got one valence electron. Its ionization energy is lower. Okay. First ionization energy, this one's 520, that one's 495. It's going to give away that electron easier. So also this one you can tell, can you guys tell on the zoom? That one's shiny. Can you guys see that? I got a big chunk of sodium. So this one should be, so we're still it's gonna do the same thing. It's gonna make the hydrogen gas. And then, what is that thing? Oh, it's on here. There we go. Didn't I just have a rag? Oh, that's filthy. Thought I had a wet rag. What the beans? All right, here we go. Let's do sodium. Ready? Sodium. Sodium. Describe what happens. Oh, hey, what's that? That's on. That's whoa. Hello. Is that different? Ah, yeah. Woo! Hot dog.
I want to ask, did you expect that to happen?
My heart rate right now would tell you no, that I didn't expect that to happen. My experience would tell you yes, that is a thing that happens. Did it happen when I did it yesterday or last week? No, it didn't. No, it didn't. Has it happened before? 100%. That has happened before. And so what, dude, what just happened? Okay, not cool. That was freaking amazing. It scared me too, so that's appropriate. That was appropriate. So sorry, Zoom, you can't see my face and you didn't see me jump and almost pee myself a little bit. Although that's what happened. Okay, so, whew, yeah, science. That's more fun. That's I didn't even get flames when I did it with Honors Chem last week. I didn't even get any flames. And they were like, it bubbles more.
Did you put more than last time?
Yeah, I probably put a little bit more in. Okay, so here's what we did. Instead of lithium, we had sodium. And so we did the same thing here. Am I sharing my screen? I'm not sharing. Sorry. So we did the same exact reaction, except now we have sodium hydroxide and hydrogen gas. Now, what else did we appear to have? Like something else that was obvious there that we didn't see before. Fire. We had a whole bunch of energy released. Okay, now the energy, this is tricky because there's no, like what exploded? Do you know what exploded right there? What we got was we got H2 and with a little bit of oxygen in the room. And then you put some hydrogen gas and some oxygen together with some energy, and that equals boom. Yeah? Right? So did you guys see when I first put it in, there was like a bubble around it? That was hydrogen gas. It was forming a bubble of hydrogen gas. And then we got enough oxygen, we got the right ratio of oxygen and hydrogen and the energy to go boom. Because there was the oxygen, this was in the room. That was in the room. Okay? Whew. Was that more reactive, just slightly more reactive than lithium?
Yeah.
All right, okay, cool. So we all agree that was slightly more reactive than lithium? Okay, just a little. Okay. All right, do we answer this? Why is sodium's valence electron easier to remove than lithium's? It is further from the nucleus because it is in one more energy level. 1, 2, 3, 1, 2. Yeah? So even though it is a more attractive nucleus, the valence electron is further from the nucleus. Whew. Okay. Heartbeat hasn't slowed down that much. All right, let's do calcium. Is calcium bigger or smaller than sodium? Calcium, so it's tricky when you do things that are not in the same group or the same period. So we have one more energy level. Should it be more reactive? Okay, we got one more energy level. And is it bigger? It is slightly bigger than sodium. So, okay, here we go. I'm going to stop share. We're going to put some calcium in there. Okay. It's cool, you guys. I got this. It's cool. Did you guys see that? I'm getting another rag. I got to clean that screen off so you guys can see what's happening. Okay, we're gonna get some calcium. Everybody cool? We're all back. We're all back to we're all good. Yeah. Okay. Well, you guys can't see anything. It's probably worse. Okay. Here we go. I got some calcium ready to go. I got a chunk of calcium over here. Calcium, which people don't tend to think of as a metal, is definitely a metal. They call these the rare earth metals or alkali earth metals. And I'm going to go on this side of the... Yes, here we go. Calcium metal in water. Calcium. Hey, calcium. What's happening? There's some bubbles. There's making some bubbles. Yeah, you can't see them. Is there much happening? No. How many electrons do we need to remove from calcium in order to make it react? How many valence electrons does it have? It's got 2 valence electrons. Do you know how many valence electrons you need to remove for it to react? Say 2 again. 2. You have to get rid of all the valence electrons in order to react. So calcium, although it might appear to be more reactive because it's 1 more down on the periodic table, is also 1 to the right. So it is less reactive. Oh, did you predict? Dang it! Forgot to do that. So why did this happen? Calcium has 2 valence electrons to get rid of, so it's going to be less reactive. All right, I'm going to put the sodium away. Did I put that in the water? I did. So if these are wet and then I go and I touch the sodium over there to put it back in the container, I don't know. Sometimes you'll get little chunks of sodium like in the water over here, like when it explodes like that. And then you'll be like, I'll like spray water around and get little flames popping up. It's pretty exciting. Okay, so you go back in there. Oh, by the way, I don't know if you guys saw this, but the sodium, it's in this container with oil because oil shouldn't have any water in it. It goes in this container. And then in this container, there's things that absorb a bunch of like sand type things, like kitty litter that absorb water. So we don't want that reacting. Calcium, calcium's just in this jar. All right, potassium, K. What's going to happen? Okay, it's going to react. It's in this safety can. It's packed in oil. You should be getting slightly nervous and excited. This jar of potassium, I feel like, is older than me. It's really old. Sorry, folks on Zoom can't see that, but it's old. It's old. You can't take her stuff. She's too old. That's from Happy Gilmore right there. All right, here's what's going to happen. I got some potassium. I got to get my camera set up going so we can see potassium react. And you're going to compare the reaction to that of sodium. So once again, sodium was bubbling, and then it caught on fire, and then it exploded, and we all got a little nervous. Yeah? So potassium. Potassium has 1 valence electron. It's going to get rid of it. It's going to get rid of it pretty darn... Whoop. Sorry, you guys can't see. Sorry. There we go. You guys almost let me do that where you couldn't see. Get in there. Ooh. Did that go right away? Yeah. Ooh. Did that react quicker than the sodium? It reacted quick. It didn't explode. So you guys are like, I don't know, Mr. Miller. It didn't explode. Also, look at the color. Watch this. Watch the color. It doesn't show up on the video very well, but that's got like a purple thing to it. Whee! I don't know if you remember from first semester, but we talked about different atoms There are electrons moving up, bouncing up and down. Energy levels will emit different frequencies of light. And so potassium's color is kind of purpley. So your job was to do all that stuff